Let's walk inside the main museum. So sometimes in Second Life, I can use the built-in physics. And this one here with the giant dominoes does that. So I'm going to hit the little finger on the left side here. And it will push on the first domino. Which pushes the second, which pushes the third. And each domino is 1.5 times higher, 1.5 times wider, and 1.5 times thicker. So by the time it reaches the end of the line, the energy has been amplified by 1 billion times. And I actually have one of these in real life in the Exploratorium as well. And when that final one comes down, it makes a huge boom. This one will also reset by itself. To your left over here, there is what the Transportation Security Administration really needs. It's a body scanner. And as I walk through it, my body completely disappears. And you only see the items I'm carrying. So it gets around all those worries about personal space.
Oh, you're not carrying anything.
Yeah, so it's only prims. It only shows prims. So clothing that is in the clothing layer completely disappears. So we do like a little humor here.
Completely invisible.
This rotating cylinder is the first exhibit I built in February 2006. And the real museum has a flat wall covered by this pattern. And the lines, they're all parallel, they're all horizontal, but they sure don't look it. So I took that pattern and wrapped it on a rotating cylinder in Second Life. And so now it's a combination of this illusion and M.C. Escher. The lines appear to come together and spread apart forever. Well, one visitor came from the Eureka Science Museum in Helsinki. And he saw it and had his museum actually build it in the real world. And he then sent me a YouTube video which shows this exhibit in real life. So it's the first known exhibit in Second Life in a science museum that was immediately stolen by another science museum. But he gave me credit. And when we have a momentary break, I'll actually get the URL for that YouTube video. Well, let's come down this way.
No, you're fine. Still learning how to walk.
This one is the classic Newton's balls experiment. And the thing is, this is Second Life. And so instead of just having the desktop toy, you can ride it.
All right, Mr. Kirkwood.
So go ahead and sit on the far end ball. And now, when I press the sign, oh, we got a little slow here today. There we go. And as in the real toy, the middle balls stay still and only the end ones go. Yeah, we're having a little lag today.
You're just too heavy.
That was too heavy.
Kirkwood needs to go on a diet. Yay, Marla.
Whee!
So that's one of the great things about physics in Second Life, is that you can actually participate in the ride. Okay, so hopefully you have picked up the landmarks out in front of the museum.
So everybody click on that.
I'll walk back there just in case you haven't.
I think we have a couple that have not done that yet.
So follow me again. There are many, many exhibits to explore here. So click the orange box and get the list of landmarks in a folder named Splo Tour. Now, in 2007, an asteroid almost hit Mars. Before we knew it was going to miss, I actually made a version of the impact here in Second Life. So I'm going to take you to that Mars impact simulation. And you should realize it's 1/6 scale and 1/6 speed, because it would be far bigger than one sim if I made it full size.
I only see 1 in 7. What did I do?
We'll click on it again.
Where does he want us to go?
Okay, so on your list of destinations, this is number 3,
Oh,
Destination Mars.
Click on the box again.
So go ahead and find the Splo Tour folder, and then click on Destination Mars. And I'll see you there.
That's it. I'll send it to you. Does everybody else have the landmark?
Everybody okay with that?
We just have one problem. I just sent you the landmark. Did you get it? Oh, did you?
How can I find it, kid? I mean, if it popped up on my screen, I'll ask it already.
There we go. So have a seat. Set the world to to midnight, and I'll run the simulation. So all of my big exhibits run on the same system. So over to your right, you'll see a green ball, and I will touch that, and it will start the simulation. Now, actually, I should point out to you that I am a planetary physicist, and so I made this as realistic as possible. And in fact, the sky that you see is from an actual image that the rovers took of Mars, and that's the Martian sunset. And on Mars, the sky is salmon colored, but the sunset is blue, just the opposite of Earth. So here we go. We'll see what happens when an asteroid hits Mars. And by the way, this is very loud. So nice night sky on Mars. Alas, for Linden Mars, we have the Earth's moon. Here comes an asteroid. So those are actually real physical boulders, and if they hit anybody, they'll actually hit them. As I said, in real life, this will be 6 times bigger and 6 times faster than that. So this is very slow motion. Real impact has the energy of a very large nuclear explosion. This yellow wall is the last wave. The white outgassing is actually water vapor. We know that underlying most of the surface of Mars is a layer of ice. And so an impact like this would release that ice as mist. So there it is, quieted down a bit. And now you can walk over and take a look at the crater. Although we've covered the crater with a clear, transparent coating.
Very nice.
Wouldn't want you to get your feet dirty. So this is actually an image of a crater on Mars taken by the rovers. And so I really try to make the textures. The depth to width ratio is correct. The height of the rim is correct. And it's just really slow. But that goes along with the scale.